Okay guys, so this is going to be free response set number 6 notes. So it says a tank has a height of 10 feet and the horizontal cross sections are given by the table above. It says it's continuous and it decreases as h increases. So for part A, it says use a left Riemann sum with 3 subintervals. Okay, so we're going to do 2, 3, and 5. And left Riemann sum, we're going to use left points. Okay, so we're going to do 2 times 50.3 plus 3 times 14.4 plus 5 times 5 times 6.5. Okay, so we do this. Okay, so we should get 176.3 cubic feet. Okay, now part B. It says, does the approximation in part A overestimate or underestimate the volume of the tank? Okay, so since this graph is decreasing, to give you a little visual. So since it's decreasing, because it says it is, the tangent line is going to be above it, right? Okay, so if it was asking about the tangent line, yeah, that would be the overestimate. But we're talking about areas in overestimate, underestimate. So if it's concave down or if it's decreasing, our left-hand point has to be on the graph. Okay, so you can see when we go to make our rectangles, something like that, it's going to be greater than, so this is going to be an overestimate. So it's going to be overestimate. Okay. Decreasing, so LRAM gives overestimate. Now remember, on RRAM, your right-hand point is going to be on the curve. So that's how you do that part. Okay, C. Okay, it says the area in square feet is given by f of h. Based on this model, find the volume of the tank. So if we integrate your area function, 50.3, over e to the 0.2h plus h from 0 to 10 feet, because that's what your height goes from, we'll get the volume. So the integral of area gives us volume. So we do 50.3 divided by e to the 0.2x plus x, close parentheses, quit, math 9, vars y1, comma x, comma 0, comma 10. Okay, so you get 101.325. And it's cubic feet for your volume unit. Part D, it says water is pumped into the tank. When the height of the water is 5 feet, the height is increasing at a rate of 0.26 feet per minute. Use the model from part C to find the rate at which the volume of the water is changing with respect to time. Okay, so we know that this gives us volume. The integral of this function gives us volume. Okay, so volume is equal to the integral of 50.3 e to the 0.2h plus h. Now if I want to find the rate at which the volume is changing, this is going to be a related rates question. So we're going to say dv dt. If I take the integral, the derivative of integral, we just get the original function. Okay, so we get f of h. And then we have to take like a chain rule. So we have dh dt. Okay, so so we're going to plug in a 5 into this function right here, and you should get 6.517. And dh dt, So once again, we get the 6.517 by taking a 5 and plug it in right here. dHdt is the rate at which the water height is changing, which is 0.26. And you should get 1.694 cubic feet per minute. Okay. So we should be pretty good at the LRAM, RM stuff. We should be able to integrate in the calculator pretty easily. You know, a little bit of related rates. Don't forget your second FTC when I take a derivative of an integral. The integral goes away. Okay, next question. Famous banana problem. Okay, it says that customers remove bananas from a table. Okay, so it is remove. They're being put on the table after it's been open for 3 hours. Okay, so they're putting bananas on the table right there. And you initially have 50 pounds of bananas. Okay, so part A, it says how many pounds of bananas are removed from the display during the first 2 hours of the store opening. So what we're going to do is we're going to integrate from 0 to 2 of f of t dt. Okay, so that gives us an amount. Anytime we integrate an amount, a rate, we get an amount. So we're going to put that in our calculator. So 10 plus parentheses 0.8x sine of x to the third over 100. Okay, so math 9 vars y1 comma x comma 0 comma 2. So you should get 20.051. Okay. Okay, next part B. It says how many pounds, f prime of 7, and we want to explain the units and the context of the problem. So f prime of 7. Okay, so I already have f in my calculator. So I'm taking the derivative. So we do math 8 vars y1 comma x comma 7. And I get negative 8.1195. Now this is going to be pounds per hour per hour. Okay, so if I'm explaining the meaning of this, this is the rate at which bananas are being removed from table is decreasing at 8.1195 pounds per hour or pounds per hour squared, however you want to write it. Okay, part C is the number of pounds of bananas on the table increasing or decreasing at t is equal to 5. Give a reason for your answer. Okay, so I'm going to call this A of t like kind of an accumulation function. Okay, the way I tell if things are increasing or decreasing is I take a look at the derivative. Well, my derivatives are given by the rates, okay? So I'm putting stuff on the table. So A of t is what's being put on the table, so it's g of t. And then I'm removing by f of t. Okay, so I'm removing by f of t. I'm about to adjust my camera because it's not very high. Okay, so what we're going to do is we're going to plug in, we're evaluating at 5, so g of 5 minus f of 5. Okay, so what we can do is we can leave that in there. And I'm going to actually change that real quick. 3 plus 2.4 natural log of x squared plus 2x. And then I'm going to put f of t in my y equals. So 10 plus 0.8x sine of x to the third over 100. Okay, and I'm just going to use my table. Okay, so I'm evaluating it at t is equal to 5. So those are my two numbers I'm going to be using. So we're going to do 11.533 minus 13.796 and so you get a negative 2.63 bananas per hour. Okay, and it's decreasing because it's negative. So the rate, so you're actually removing more than what's being put on the table. Okay, part D, it says how many pounds of bananas are on display at t is equal to 8? Okay, so I want to know an amount. Okay, so I initially have 50 pounds of bananas on the table when the store opens. Okay, I am putting bananas on from 3 to 8. Now you need to make sure you pay attention to this right here. It starts at 3 and ends at 12. Okay, so I already have that in my y1, and then I'm going to subtract out what's being removed, my f of t. Okay, so put that in the calculator. So I'm going to integrate this from 3 to 8, and g of t is in y1, so math 9 vars y1 comma x comma 3 comma 8. Okay, so I get 58.9641. Okay, and then I'm going to math 9, I'm going to integrate y2 from 0 to 8. You get 85.6166. So we do 50 plus 58.9641 minus 85.6166. And you get 23,3475 pounds of bananas. Okay, so that's how we do an accumulation problem. Okay, derivative graph and function divided by an integral. Okay, so when we have a graph like this, our first step is to identify our critical points. So our critical points are right here and right here. Now remember, and also right here, that could be considered a critical point, but it's not going to cross. So now remember, when we go from positive to negative, it's going to be a max. Negative to positive, it's going to be a min. Okay, so it says find the value of f of negative 6. So what we're going to do is we're given f of negative 2. So that's going to have to be involved in all of my integrals. So the integral from negative 6 to negative 2 of f prime of x dx is equal to f of negative 2 minus f of negative 6. Okay, the integral is represented by the area, so we're going to find the area. This is going to be a triangle. So it's 1, 2, 3, 4 by 2 is 8, so this area comes out to be 4. Remember, if it's above the x-axis, it's positive. Below the x-axis, it's negative. Okay, f of negative 2 is given to us as 7. So that means f of negative 6 comes out to be 3. Okay. Next portion, we're going to deal with 5. So we're going to do the integral from negative 2 to 5. And we're going to always write our smaller number on the bottom. is equal to f of 5 minus f of negative 2, like that. Okay, so we're gonna integrate from negative 2 to 5. So this is a semicircle. The area of a semicircle is pi over 2 r squared. Your radius is 2. So your area comes out to be 2 pi. So each one of these is a little pi, just in case we have to split it up later. Okay, so it's negative 2 pi because it's below the x-axis. And then you got a 1, 2, 3. 3 by 2 is 6. 6 divided by 2 is 3. Okay? So the total area from negative 2 to 3 is negative 2 pi plus 3. We're looking for f of 5. And this is going to be minus 7. Okay, we're going to add that to the other side. Okay, so you get 10 minus 2 pi. Part B says, where is f increasing? F is increasing. Where f prime of x is positive or greater than 0. So we're looking for positive y values. Okay, so we have positive y values from negative 6 to negative 2. In union with 2 to 5, right? Part C, absolute min value, okay? And I want to justify my answer. Okay, so when we do absolute max or min problem, we're going to consider our critical points. So your critical points are going to be x is equal to a negative 2, x is equal to 2, and x is equal to 5. And 5 is also an endpoint. Okay, so your endpoints are x is equal to negative 6, and x is equal to 5. Okay, so I know, and this is kind of weird because how they grade on some of them, but to get a y value, you're going to have to integrate and do just like we did up here. So we're looking for min. Okay, so I'm going to say it's probably not going to be this one because that's a max. It'll probably be either this one or one of the endpoints. Okay, so we're going to do the integral from negative 2 to 2 of f prime of x dx is equal to f of 2 minus f of negative 2. Okay, so the integral there, negative 2 to 2 is negative 2 pi. F of 2 is what we're looking for. F of negative 2 is 7, so this comes out to be 7 minus 2 pi. Okay, f of 5 already found. So f of 5 is 10 minus 2 pi. What else do we need to do? F of negative 6. So f of negative 6 is 3. And is that it? Yeah, that's all we have to consider really. If you want to consider negative 2, the integral from negative 2 to negative 2 of f prime of x dx is equal to 0. And we already have f of negative 2 is equal to 7 up here given to us. So f of negative 2 is equal to 7. Okay, so which one's the highest value out of this? Okay, your absolute min. Now remember pi is going to be 3 0.14, so 7 minus 6 is 1 point something. Or actually, this would be like 0.96, 0.93-ish. So that's your absolute min. And it appears that f of negative 2 is your absolute max. Okay? So it just asks for absolute min, so that's all you have to do. But we'll just finish it out for you. Part D, it says, find f double prime of negative 5. Okay, so f double prime is going to be the slope on the derivative graph. Okay, so at negative 5, I'm going to find the slope of this line. So I'm going down 2 and over 1, 2, 3, 4. Okay, so that's negative 1/2. If I want to find at 3, okay, so the slope at at positive 3 does not exist. Okay, so let's go through why. If I go into my slope here, your left-hand derivative, so your left-hand derivative is going to be up 1, 2, and over 1. Okay, so it has a positive 2 slope. Your right-hand derivative, okay, is down 2 over 1, 2. Okay, so it should be a negative 1 slope. Since your left-hand derivative does not equal your right-hand derivative, it's not differentiable at that point. Remember, differentiability means that it can't have sharp peaks or vertical tangents. It also has to be continuous. Okay, next question. Okay, so as we read through this, we have boiled potato is taken from a boiling pot of water, and it's left to cool, and it follows this function right here, where h is the temperature in degrees. So for part A, it says write an equation for the tangent line of the graph of h at t is equal to 0. Use this equation to approximate the internal temperature of the potato at t is equal to 3. Okay, so your initial temperature is 91. So we have to find our slope. So your slope is going to be negative 1/4 times 91 minus 27. Okay, so 91 minus 27 is 64. And 64 divided by 4 is 16. So this comes out to be negative 16. Okay. Now if I go to write my equation of my tangent line, it's y minus, let's use our initial condition of 91 is equal to a negative 16 times x minus 0. Now I'm using this to approximate the internal temperature at t is equal to 3. Okay, so at t is equal to 3, we're going to take this and we're going to plug in. So t is like x, and h would be like your y. So negative 16 times 3 is negative 48. Negative 48 plus 91 comes out to be 43 degrees Celsius. Okay, so that's how we use our equation of the tangent line. Part B, it says we want to determine if it's an overestimate or underestimate by the second derivative. So the second derivative of this thing, okay, so d squared h over dt squared is equal to, okay, if I'm going to take the derivative of this, it comes out to be negative 1/4 dh dt. Okay, and dh dt is given by this up here. So negative 1/4 times negative 1/4 h minus 27. Okay, so this comes out to be 1/16 times h minus 27. Now, at t is equal to 3, we said that the temperature was going to be 43 degrees. Okay, so the second derivative is going to deal with concavity. This comes out to be positive. So it's concave up. And we know that whenever something is concave up, the tangent line is going to be below the curve. So it's going to be an underestimate. Right. And I always draw a little picture to see where the tangent line would be, just so I know I make sure that I did it right. Part C, it says we're given this model and differential equation. It says find the expression for g of t, which means we're going to integrate, and pretty much this differential equation problem. Okay, so we're going to separate our variables. So let's go ahead and write the original. Okay, I want to get all my g terms on one side and everything else on the other. I'm going to leave that negative sign on the other side. Okay, so we're going to integrate. You have a u sub right here. Your u is g minus 27. Your du is dg. Okay, so this is going to be u to the negative 2/3 power when we go to integrate that, which is going to be add 1 to the exponent, so it's 1/3, 3, like that. So we get 3 times g minus 27 to the 1/3 power is equal to, integral of this is a negative t plus c. We're going to use our initial condition, g of 0 is equal to 91. So 3 times 91 minus 27 to the 1/3 power is equal to 0 plus c. Okay, so 64 to the 1/3 power, so the cube root of 64 is 4. 4 times 3 is 12. And so we're given this. And then we got to solve for g. Okay? So we're going to divide both sides by 3, or multiply by 1/3. And then we're going to cube both sides to get rid of the cube root. And then we're going to add the 27. Okay, so g of t is equal to negative t plus 12 over 3 cubed plus 27. And that is our solution to the differential equation. Next one is a velocity and acceleration. Velocity and acceleration. Okay, I believe this one is non-calculator. So let's make sure we do it without a calculator. Okay, for part A, it says when is particle P moving to the left? So the way we determine direction of moving is by the velocity. So v of t is less than 0. Okay, it's moving left. Okay, so we're going to take our derivative. So the derivative of natural log is du over u. Okay, and we set it equal to 0 to find the time it changes direction. Okay, so we get t is equal to 1. So when we set a fraction equal to 0, we're just going to set the top equal to 0. So 2t minus 2 is equal to 0, so t is equal to 1. Okay, so we go into our little number line. Okay, so like that. Now I'm going to plug in a 1/2. Okay, so 1/2 times 2 is 1. 1 minus 2 is a negative. If I plug in a 1/2 down here, I should get a positive. So a negative over a positive is a negative. Okay, and say I plug in a 2. 2 times 2 is 4. 4 minus 2 is positive. The bottom is going to be positive. So that's what we get right there. So this thing's going to be moving left. From 0 to 1. Part B. Find all the times where the two particles are traveling in the same direction. Okay? So we're given the velocity function for this right here. Okay, so VQ t is equal to t squared minus 8t plus 15. Okay, so this factors to t minus 5 and t minus 3 is equal to 0. Now we have to do the same exact thing we just did with the other particle using the number line. Okay, 0, 3, 5, and we're going to 8. Sorry, I forgot the 8 on that one. Okay, so we're going to plug into our velocity function to figure out what direction it's traveling. Okay, so we're going to plug in a 1. Okay, so you should get positive. 1 minus 5 is negative. A negative times a negative is a positive. Plug in a 4. Should be negative. And plug in a 6. Should be positive. Okay, so we'll know where they're traveling the same direction. So the same signs. So what I would do is I would take these points. I'm going to go to one number line. And I'm going to write their signs in there. So this is going to be positive from 0 to 3. Negative from 3 to 5, and positive from 5 to 8. So they're traveling the same direction from 1 to 3 in union with, it looks like 5 to 8. Okay? Ta-da, you're done. Part C, find the acceleration of particle Q at t is equal to 2. Okay, so acceleration is going to be the derivative. Okay, so I'm going to take the derivative of q, so you get 2t minus 8. Okay, so I'm evaluating it at 2. Okay, so you should get a negative 4. Now, it says, is speeding increasing or decreasing? So remember, we look at the velocity also. Okay, v of 2 for particle q is this number line down here, and it's positive. Okay, down there. And if you want to actually get a positive value, so 2 minus 5, negative 3 times the negative 1, so it should be a positive 3. Okay, if you want to get that, an actual number for it, or you can just look at the sign. So remember, if they were the same signs, the speed is increasing. Opposite signs, speed is decreasing or slowing down. That's fine with me, however you want to say that. Okay, to find the position of a particle, the first time particle Q changes direction is going to be at t is equal to 3. Okay, so we're going to integrate to find position. Okay, is equal to x of 3 minus x of 0, our first FTC. Okay, so we're going to integrate this function over here. So integral of t squared minus 8t plus 15 dt. Okay, so this becomes 1/3 t cubed minus 4t squared plus 15t, and I'm going to go from 0 to 3. So I'm plugging in a 3, I get 3 cubes 27. I'm just going to write it out. Okay, so 3 cubes 27, 27 divided by 3 is 9. Plug in a 3 right here, you get minus 36 plus 45, and if I plug in a 0, I get 0 for everything. So I get 18 for that. X of 3 is what I'm looking for. The initial x position is 5 at t is equal to 0. you get 23 for your final x position, where it turns around for the first time. Yeah, we should be pretty good at those. Okay, if I was to predict what type of question would be on the 2020 free response with this COVID stuff and it being a shortened free response and, you know, multiple parts, that sort of thing, where you couldn't cheat, if it was open note, open book, that sort of thing, it would be this type of question, okay? So this is a really, really good question. Okay, so this is a really, really good question. Part A, it says find the slope of the tangent line of the graph of f at x is equal to pi. So f prime of x, so your f is up here. Okay, so the derivative of cosine is going to be negative sine of 2x. You gotta chain rule it. And the derivative of e is e to the u du. Like that. Now we're plugging in a pi. Okay, so negative sine of 2 pi times 2, e to the sine of pi, and cosine of pi. Okay, so if you don't know where pi is, pi lands you right here. 2 pi is going to land you right here. Okay, so sine of 2 pi is 0. The y-coordinate at 2 pi is 0. So e to the sine of pi, that goes to 0. E to the 0 is 1. Cosine of pi is a negative 1. And that's it. Part B. It says, let k be a function defined by h of f of x. I want to find the derivative of that. Okay, so we're going to take the derivative of the outside, keep the inside, and then we have to chain rule the inside. So we're going to plug in a pi. Okay, so f of pi. Okay, so we get f of pi from plugging into our function up here. So f of pi. Okay, so cosine of 2 pi is 1. E sine of pi. Sine of pi is 0. E to the 0 is 1, so this comes out to be 2. So that comes out to be 2. Okay, h prime of 2. So h is given by this graph up here, so we're looking for the slope of this line at 2. Okay, so it's down 1 over 1, 2, 3. Okay, so we get negative 1/3. And then f prime of pi is negative 1. We get 1/3. That's it. Part C. Okay, m of x is equal to g of negative 2x times h of x. And I'll find the derivative of this. Okay, so write the first, you get a product rule. Derivative of the second, plus write the second term, derivative of the first term. Don't forget your chain rule. That. Now we're evaluating this at 2. So g we're going to get from the table up here. So g prime negative 4 is a negative 1. H prime of 2. Didn't we already find that? h prime of 2 is going to be a negative 1/3. Found that from the graph. H of 2 is the y value. Okay, so this is going to be negative 2/3 because the slope's going to be down 1/3. Okay, so negative 2/3. Okay, g prime of negative 4 is negative 1. Hold up, no, I wrote that wrong. Haven't woke up yet, sorry. This should be g of negative 4. So g of negative 4 is actually 5. Okay, and g prime of negative 4 should have been negative 1. Okay, adding all this stuff together, you get negative 5/3 plus a negative 4/3. So you should get negative 3. That's what it comes out to be. Okay, part D. It says, is there number C in the closed interval such that g prime of C is equal to a negative 4? Okay, so G, we're looking in between negative 5 and negative 3. Remember, this is going to be MVT. Okay, so with MVT, we have to say that it's continuous and differentiable. Okay, and we're going to say that g of negative 3 minus g of negative 5 over negative 3 minus a negative 5. So we can use our table. G of negative 3 is 2. G of negative 5 is 10. Over 2. So we get negative 8 over 2, which is negative 4. Therefore, MVT guarantees at least one C. Okay. Okay, A, B, you can do the first two parts of this question and then you're done. B, C, we got 2 more little questions to go. Part A, this is find the slope of the tangent line at x is equal to 3. So we're going to use quotient rule. So we're going to write the bottom. Derivative of the top is 0. Minus, we're going to write the top, which is 3. Derivative of the bottom is going to be 4x minus 7. All over the bottom squared. Okay, so we should get negative 12x plus 21 over the bottom square. Okay, now I want to evaluate this at x is equal to 3. Okay, so we get negative 36 plus 21 over 4. Okay, so you get negative 15/4. Okay, that's it. Part B, find the x-coordinate of each critical point in between 1 and 2.5. Okay, classify it as a relative min, max, or neither. Okay, so we have our derivative graph. Our critical points, we're going to set the top equal to 0. Okay, so, and the bottom equal to 0, but the bottom's not going to ever equal to 0, so you're good there. So we get x is equal to positive 7/4, which is what, 1.75? So if I want to classify this, I'll make my little number line. We're starting at 1. And we're going to 2.5. Okay, so if I plug into my derivative, the bottom is always positive because it's squared. We're going to plug in 1.5. Okay, so you should get a positive. Okay, and then if I plug in a 2, you get negative 24 plus 21 is a negative. Okay, so this is going to be a max because it goes from positive to negative. So we say local max at x is equal to 7/4 because it f prime of x goes from positive to negative. Okay, that's it, A, B. So BC, we're going to keep continuing. Okay, so part C, it says use the identity that 3 over 2x squared minus 7x plus 5 is equal to 2 over 2x minus 5 minus 1 over x minus 1. Okay, so what they did is they did a partial fraction right here, but we don't have to do that work. It says evaluate the integral from 5 to infinity. Okay, so this is going to be an improper integral. When we do improper integrals, we take the limit as t goes to infinity of 5 to t, and we're going to integrate this right here. Okay, so we have a little u sub. Your u is 2x minus 5. du is 2, so we don't have to manipulate that. So when we integrate this, look at that. Now, what I would do, since there's subtraction with natural logs, I'm going to combine them by division. Okay? Now, when we do natural logs of at infinity, okay? So we're doing our limit as t goes to infinity. So if I was going to do a limit at infinity, your top heavy, bottom heavy rules apply. So they're the same power, top and bottom. So this is going to go to natural log of 2. And then if I was to plug in a 5, 5 times 2 is 10, 5/4. Okay? You can leave it like that, or you can simplify this. By division again, when you divide, you're going to multiply by the reciprocal. So as long as you get an answer, it's fine. It's convergent. Okay. Part D, it says determine whether the series of this converges. Okay, so we were told that this function right here is what we just did. Okay, same limits and everything like that, 5 to infinity. So we can use integral test. Since the integral from 5 to infinity of 3 over 2x squared minus 7x plus 5 is convergent, and it's continuous and decreasing, then by integral test, the series of 2n squared minus 7n plus 5 also converges. And 5, like that, something like that. Okay, so it pretty much did the integral test on this portion right here. Okay, so make sure on limits at infinity, we're going to use the limit infinity for this portion right here, and use your top heavy, bottom heavy rules. Okay, so you're going to have to divide the leading coefficients that are the same power, and so that's where we get the 2 from. Okay, last question. We will not do part D on this on the series bound. It's not going to be tested on 2020 test. So, anyways, so we're given that f of 0 is equal to 0, f prime of 0 is equal to 1, and the next term is equal to the previous term times the previous derivative. Okay, so that's what that means. This means previous. Okay, so what we're going to do is so we're going to write a Maclaurin series, and then we're going to write the general term. So, so what I'm going to do is I'm going to go f of 0 is equal to 0. Just we would take our regular derivatives. F prime of 0 is equal to 1. F double prime of 0. Now we're going to follow the pattern because it says, starting here, we're going to follow the pattern. So it's going to be a negative 1, so the previous term, times the previous derivative. Okay, and then keep going. Third derivative. It's the previous term times the previous derivative, which is a negative 1. So it's going to be 2. Okay, and then the fourth derivative. Previous term times a negative, and then times your derivative, which was 2. So it's a negative 6. So if I go to write my Maclaurin series for this stuff, you write the first term is 0 plus 1 times x minus 1 over 2 factorial x squared plus 2 over 3 factorial x cubed minus 6 over 4 factorial x to the 4th. Okay, and then if we were to simplify this, get 1/3 x cubed minus 1/4 x to the 4th. Okay, so when we go to write our general term, this is n is equal to 1, n is equal to 2, n is equal to 3, and n is equal to 4. So our general term okay, so what we're doing is we're alternating sign. Okay, and our x is being raised to the n power, like that, and we're dividing by n. That's it. Okay, determine whether the series described in part A is going to be conditionally convergent, that sort of thing. Explain your reasoning at x is equal to 1. So what we're going to do is we're going to take a 1 and we're going to plug it in. Okay, so 1 to the n over n. Okay, so 1 to the n power is always going to be 1. So what we have is an alternating harmonic series. Now, when we talk about doing absolute convergence and conditional convergence, we have to look at this and we have to look at the absolute value. So this is going to be alternating series test of b sub n is 1 over n. It's decreasing. And we're going to do the limit as n goes to infinity of b sub n is equal to 0. Therefore, converges by alternating series test. Now, make sure on your AP test that you write that out, alternating series test. You have plenty of time to do it. Now, let's do the absolute value of this. Okay, so if I was to take the absolute value of this, we just get 1 over n. And 1 over n diverges by P-series test. This is going to be conditionally convergent. Okay. Part C. Write the first 4 non-zero terms in the drill term for the integral. Okay, so we're going to integrate this right up here. So g of x is going to be equal to 1/2 x squared minus 1/6 x cubed plus 1/12 x to the 4th minus 1/20 x to the 5th. And when I integrate the series, okay, we're going to add 1 to the exponent. We're going to divide by the new exponent. And we're just going to leave it just like that. Ta-da, you're done. Okay, so this has been free response note set number 6. Make sure you pay attention to any of the graph problems or table questions. Things that you think that you would be able to do on an AP exam test with having open notes, open calculator, and not be able to cheat. So make sure you look at that, that problem back here, number 6, before starting your AP exam. Thanks and have a good day.